In the previous lesson, we learned how to use this beautiful stoichiometry flowchart right here. And basically, we take our given, which is the starting values, and we time the conversion factors. And we create our answer something look like this, okay? To solve for the unknown from the given. Now, today we are going to look at this right here. How can we interpret this setup into fraction so that we can cancel out the unit and chemical to solve for the unknown and actually plug into the calculator. So in this case, what I have here is a chemical reaction required 0.5 moles of carbon, and that would be our given. Notice how we have the number. Think of given. We are given the values of how much we're starting with. So that's your given. And how many grams of carbon are needed? And that is our question mark, grams of carbon. Flowchart. In this case, I'm starting with my given and time the conversion from moles to gram. If we go back over here and look at our map, this is our mole right here starting. Okay. And where did we end? Grams. So from here to there, we multiply that conversion factors right there. And if you notice all the major conversion factors that we have used so far, all of them, both of the measurements have number, either 1 or in this case the Avogadro number, or in this case if liters 22.4 liter, but they all, both of them have numbers, except for the conversion factor in terms of 1 moles of A equal to number of grams of A. This number of grams is also known as the molar mass. And that conversion factor is actually called molar mass. And notice how it is a number sign. And that is because this depends on the chemical. So what you can do is you can actually Google for the molar mass of the chemicals if it's not given to you. So that's what we're going to focus on today. How can we find the molar mass of a substance if you need it? If you're using this conversion factor in your flowchart, then you need the molar mass. So let's look at one example. So in this case, we set up from mole, and to gram, we multiply by that conversion factor. So this right here is your molar mass, okay? And what is the molar mass of? Well, what is the chemical? In this case is carbon. So what do you think I'm gonna able to do using the power of the internet? I can just actually Google for the molar mass of carbon. Later on, I will show you how to calculate for molar mass of any substance. But for now, let's look it up. So molar mass of carbon. And what do we have? We have 12.01. And basically that number go right over here. So this number right here is actually equal to 12.01. So now let's combine everything together so that we can simplify it and rewrite this as a fraction. And the trick to rewrite this fraction is starting from the very beginning of your flowchart, which in this case is question mark grams of carbon. This is what we are solving for, okay? So after we rewrite as fraction, our final answer must have grams of carbon. Then we get our given right here, which is 0.5 moles of carbon, and we time this conversion factor. Notice now this conversion factor is not like the givens only have one measurement, but the conversion factor has two measurements. The question is this: if we rewrite this as a fraction, which one go on the bottom? Is it the 1 moles of carbon or the number of grams of carbon? Well, the strategy is this: the denominator measurement must have the same unit and chemical, both of them, okay? Both. The unit and the chemical, the same unit as the unit and the chemical of the numerator. This is the number on top of a fraction. And the denominator is the one on the bottom of the fraction, okay? And must have the same unit and chemical of the numerator from the previous measurement. In this case, if this is a conversion factor, this must be the previous measurement. So the previous measurement has moles of carbon, so down here must have moles of carbon. And it should be directly from the conversion factor. You notice how we have moles of carbon right here. And how many? Of course, just one. Notice how I copy exactly from that one side. If this side is on the bottom, the other side must be where? on top of the fraction, of course. And of course, it's going to be number of grams of carbon. Well, I know exactly how many grams it's going to be. It's going to be 12.01 grams of carbon. And if you notice, we're pretty much done because we don't have any more conversion factor to multiply. So notice how the unit mole of carbon cancel out. And all I have to do is plug into the calculator 0.5 times 12.01. And notice how we have grams of carbon left. If I were to plug this into the calculator, this actually equal to, so what I have here is 0.5 times 12.01, and that will give us 6.005. Of course, I'm still going to keep 2 decimal places. In this case, we have 6.00 grams of carbon, and that is the answer. So if we go down here and we plug in our answer, so I divide into 2 parts. So that way you get partial credit, and the numbers will be 6.00, and the unit in this case is grams of carbon. And that's what I mean by showing your work. If I give you this flowchart, this would be your work right here. Now, in this case, we have our unknown ions of calcium 2+, and we are given 3.7 moles of ions of calcium 2+. And I gave you the answer already to the setup of the flowchart, which I expect you already know how to do already. And our job is to rewrite this in fraction. So we have to cancel it out, okay? So let's rewrite this as a fraction. Of course, I always start from my unknown. That's what I'm looking for. So I know that my final answer must be in that unit and chemical. So ions of Ca2+. Then I continue with the flowchart, which in this case 3.7 moles of calcium 2+. Okay, and here is where it's going to get tricky. Okay, notice how we take a given. We don't have to worry about anything because there's only one measurement. But when we multiply to a conversion factor, that equal sign should be there. We have to look at which size or which measurement of the conversion factor go on the bottom. And the same strategy as before. The denominator must have the same unit and chemical as the numerator from the previous measurement. In this case, this is our previous measurement. Okay, let me write this out for you. So our numerator over here must have moles of calcium. So I know for sure that one of the measurements must have moles of calcium 2+. If it's not, then we did something wrong with the flowchart setup. And there you go. We have moles of calcium 2+. Exactly how many? 1. And I just copy exactly from the conversion factor. So if this is on the bottom, the other part must be on top. So we have 6.02 e to the 23rd ions of calcium 2+. And notice how moles of calcium 2+ cancel out and give us our ions of calcium 2+ only. Now, if I were to plug this into the calculator, I would plug on 3.7 times 6.02 E, and that E button can be represented by double E or EXP, okay, 23. And our final answer should be in ions of calcium 2+. So let's plug this in our calculator. So we have 3.7 times 6.02. Here we have EXP right there, 23. And our answer is 2.23 e to the 24. That means 10 to the 24 power. So in this case, our answer is equal to, what is it again? 2.23? 2.23 e to the 20 what? 24. And what's the unit again? It is ions of calcium 2+. So going back to our answer, we're going to put in 2.23 e 24, and then our unit in this case and chemical formula is ions of Ca 2+. And notice in this case, do we have to look for the molar mass? No, because we didn't use that conversion factors, right? That's why I say only Google for the molar mass of the substance if needed, okay? In this case, we didn't use that conversion factor, so we don't need the molar mass. In this case, we have a container contains 1.5 grams of oxygen gas, how many liters of oxygen gas are at standard temperature and pressure? Now this is STP. If we look at the flow chart, okay, this conversion factor can only be used to solve for moles of gases, okay? But it also has to be in condition as STP. So this condition allows us to use that, okay? Keep that in mind. That does not mean that when you see the word STP, you're going to use that conversion factor. So don't get tricked by me. So in this case, I set up a flow chart for you already. We go from grams to liters. And then we go back to the flow chart. From grams is up here. Let me erase this right here. From grams is up here. This is where we start right here. Okay, this is where we start. And to liters down here. And of course, I'm going to multiply this conversion factor and followed by that conversion factor. And notice how we have this conversion factor with the number of grams of A, which means we have to Google for the molar mass. So let's go back to the problem. Now the flow chart's already setting up for you already. And of course we have a given right here, times the first conversion factor. And this is our second conversion factor. And this is where the molar mass is going to be. And in this case, what is the molar mass of? And of course it's going to be the molar mass of, what's the chemical in this case? Oxygen. So let's go back to Google and look for the molar mass of oxygen. And all I do is type in O2. Enter. And we have 15.99. Let's round that to 16, okay? In this case, our molar mass for oxygen gas is 16.00. How about that? So that's 16.00 right there. So that go there. And now let's rewrite this as fraction and cancel out the unit. And of course, I always starting from the very beginning, which is what I'm looking for, liter of O2. And then start next with my given 1.5 grams of O2. And notice I don't have to worry about fraction yet until I see my conversion factor. Now I see my conversion factor. And the same strategy again, the denominator measurement must have the same unit and chemical as the unit and the chemical of the numerator from the previous measurement. So we look at the conversion factor. This is a previous measurement. So we have 1 moles of O2 equal to 16.00 grams of O2. So if this is gram O2, unit and chemical, down here must be grams of O2 as well. And of course, we have our grams of O2 right there. How many? It's going to be 16.00. And if this is on the bottom, right here, the other one must be on the top, the numerator. So we have 1 moles of O2. Unlike the other problem where we only have to multiply by one conversion factor, in this case we have to multiply by 2, so let's continue. So grams of O2 cancel out, okay? Now let's multiply by the next conversion factor, which is this one right here, our second conversion factor. And of course the previous measurement now is mole O2 is no longer grams O2, right? So in this case, if we look at this, we have moles of O2 equal to 22.4 liter of O2. Which one is going to be on the denominator, which is the bottom? And of course, we look at our previous unit, mole O2. So this must be mole of O2 as well. And how many? It's 1. And 1 moles of O2 from here, from this conversion factor is on the bottom. This must be on the top. 22.4 liter of O2. And notice how moles of O2 cancel out, giving us a liter of O2, which is exactly what we're looking for. And of course, if I were to plug this into a calculator, it would be 1.5 times 22.4 and divided by 16.00. And the last unit that does not get canceled out is liter of O2. So let's plug into a calculator. 1.5 times 22.4 divided by 16, and that gave us 2.1 liter. So we have our final answer is 2.1 liter of O2. So we plug this in here, 2.1, and this is liter of O2. Isn't that easy? So again, we have to Google for the molar mass because we use the conversion factor that involves molar mass. Where the other problem, we don't have to. Let's try another problem. We have a chemical reaction requiring 1.5 grams of aluminum. how many atoms of aluminum are needed. Now, if we look back at the flow chart, right, starting from gram and to atoms. Now, if we look back at the flow chart, notice how we start from grams, and where do we end? Atoms of aluminum. So we go start there and go across here. So we have first conversion factor, and this is our second conversion factor. And again, we use our molar mass conversion factor. Guess what we have to do? We have to look it up on Google. So in this case, what we have here is what's the molar mass for aluminum? So let's Google molar mass for aluminum. For Al. And notice how we have atomic mass instead of using the word molar mass. That's because this is dealing with specific element. So now we know exactly what's that number of grams going to be. It's going to be 26.98. Okay? Now let's rewrite this as fraction. Of course, I'm going to have our question mark of atoms of aluminum equal to, right there, 1.5 grams of aluminum. And again, the same strategy. The measurement of the denominator must have the same unit and chemical as the previous measurement numerator. In this case, we have grams of aluminum. So down here must be grams of aluminum. And your conversion factor must have grams of aluminum, or else you did something wrong. So in this case, here we go. We have grams of aluminum. How many? In this case, 26.98. And then if this is on the bottom, which is the denominator, the other part must be on top, the numerator, 1 moles of aluminum. And that cancel out. But that's not the end of the problem. We had to multiply to the next conversion factor. We had to continue multiply all of the conversion factor. In this case, the previous numerator has moles of aluminum. So you expect mole of aluminum to be right here as well, which we have right there. So we have 1 moles of aluminum. If this is on the denominator, which is the bottom, the numerator must be this one. So we have 6.02 e to the 23rd atoms of aluminum. And there you go. We have moles of aluminum cancel out. And let's plug this into our calculator. It will look something like this. 1.5 times 6.02 e to the 23rd. And remember, e is also known as exp, or the double E button on your calculator. And our final unit in chemical must be atoms of aluminum, which is exactly what we're looking for. And of course, you have to divide it by the number on the bottom, which is 26.98. Let's plug this into a calculator. We go to a calculator, 1.5 times 6.02 e to the 23rd divided by what? 26.98. Give us 3.35 e to the 22nd. So our answer is 3.35. Is it 35? Time 10 to the, or in this case, we just use e to the 22nd atoms of aluminum. Now, that e right there also represents time 10 to the power of something. In this case, is 22nd right here, for that right there. So what we have here is 3.35 e to the 22nd. And what is our unit in chemical? It's going to be atoms of aluminum. And that's all we have to do in terms of simplify your flowchart to get our answer. And of course, this would be the work to the whole entire problem.